GFCI receptacles do not typically come equipped with auto ground clips on their mounting screws due to concerns about the reliability of such connections. Auto ground clips, which are designed to establish a ground connection between the receptacle and a metal electrical box simply by screwing in the mounting screw, are not always considered a dependable method for grounding. The main reason for this is that these clips may not consistently provide a secure and low-impedance ground path. Several factors can contribute to this. Firstly, the clip itself might not make sufficient contact with the electrical box, especially if the box is corroded, painted, or has debris interfering with the connection. Secondly, the screw threads can loosen over time, reducing the pressure between the clip and the box, and diminishing the quality of the ground connection. Thirdly, the clip's material could be prone to corrosion, which would also degrade the ground path. Because GFCI devices rely on a reliable ground connection to function correctly, manufacturers generally opt for methods that provide a more positive and consistent ground, such as a dedicated grounding conductor that is securely connected to the receptacle's ground terminal and the electrical box. Furthermore, auto ground clips might not be suitable for all types of electrical boxes. For instance, they cannot be used with non-metallic boxes, which do not provide a ground path. In situations where a metal box is used, it is essential that the box itself is properly grounded, typically by connecting it to the grounding conductor of the circuit. This ensures that even if the auto ground clip were present, the grounding system would still be effective. GFCI receptacles are required to comply with National Electrical Code Section 250.146. This section addresses the use of grounded and grounding conductors and the specific requirements for grounding equipment, especially in relation to GFCI protection. Section 250.146 mandates that under certain conditions, GFCI protection must be provided for receptacles installed in specific locations. These locations usually include areas where there is a higher risk of electric shock, such as bathrooms, kitchens, garages, and outdoor locations. The GFCI protection can be achieved through various means, including GFCI receptacles, GFCI circuit breakers, or other GFCI protective devices. The purpose of Section 250.146 is to enhance electrical safety by reducing the risk of electric shock hazards. GFCI devices operate by monitoring the current flowing to and from an appliance or piece of equipment. If there is an imbalance in the current, indicating that some of the current is leaking to ground, the GFCI will trip the circuit very quickly, cutting off the power and preventing a potentially dangerous shock. The NEC specifies that all 120-volt single-phase, 15 amps and 20 amps receptacles installed in locations such as kitchens, bathrooms, garages, and outdoors must be GFCI protected. This requirement is in place because these areas are more likely to have moisture or water present, increasing the risk of electric shock. In kitchens, water can spill near outlets, creating a path for current to flow through a person. Bathrooms have sinks, showers, and tubs that make it easy for water to come into contact with electrical devices. Garages often have damp floors and are used for tasks that involve power tools, which can have damaged cords or other electrical faults. Outdoor locations are exposed to rain, snow, and other weather conditions that can create a hazardous electrical environment. GFCI protection can be provided in several ways. Firstly, a GFCI receptacle can be installed in place of a standard receptacle. This type of GFCI has test and reset buttons on the front and provides protection only for devices plugged into that specific receptacle. Secondly, a GFCI circuit breaker can be installed in the electrical panel. This type of GFCI protects the entire circuit, including all receptacles and devices connected to it. Thirdly, a feed-through GFCI receptacle can protect other standard receptacles downstream. This setup involves replacing the first receptacle in the circuit with a GFCI receptacle, which then protects all subsequent receptacles in the same circuit. Section 250.146 is designed to minimize electrical shock risks by requiring GFCI protection in areas where water or moisture is present. GFCIs work by constantly monitoring the current flowing through a circuit. If there is a ground fault, which means that current is flowing through an unintended path to ground, the GFCI will detect this imbalance and trip the circuit. This stripping action happens very quickly, typically within a fraction of a second, which is fast enough to prevent serious injury or electrocution. The quick response time of a GFCI is critical for preventing electrical shocks. When a person comes into contact with a live electrical wire and the ground, current will flow through their body. If the current is high enough, it can cause muscle contractions, burns, and even cardiac arrest. A GFCI interrupts the current flow before it reaches a dangerous level, significantly reducing the risk of serious harm. In summary, auto ground clips are not considered reliable for GFCI receptacles due to their potential for loose connections and corrosion, and their unsuitability for non-metallic boxes. GFCI receptacles are required to comply with NEC section 250.146 to mitigate electrical shock hazards in damp or wet locations by quickly interrupting the circuit when a ground fault is detected.